All right, so I'm going to go over, we're starting the next chapter, which is chapter 14. And in this video, we're actually going to cover sections A through C, so A, B, and C. You guys said that you guys have learned some probability before, and the beginning is pretty basic, so it is something that you guys should have seen before at some point. So we are going to go through it kind of quickly. Now remember, these videos are not to master it. You just need to know this key terminology, and you need to know what it means when I ask you to find the relative frequency or experimental probability. So you just need to know these certain key terms. And then in class, we're going to go over something to kind of say what it means for probability and what happens if you have the 0.3 for a probability. Does that mean it's likely to happen or not? And we'll discuss a little bit more. But I'm going to try and get through this video kind of quickly so that way it's not that long. But we're going to go through section A first. And the first objective is just to understand the key terms. So any key term I go through with you, you need to understand. And then the next objective is to understand how to find the relative frequency or the experimental probability. All right, you need to be able to find it. So let's go through some examples or the key terms and then some examples. All right, so the key terms that you need to know, the first one is the number of trials. And the number of trials is just saying the total number of times that the experiment is repeated. So if I flip a coin 50 times, then that means my total number of trial in this case is 50. It's how many times I flipped a coin. All right, the outcomes are the different results possible for the one trial of the experiment. So once again, if we're talking about flipping a coin, are different results that we can have are different outcomes or heads or tails. All right, those are the results that we can have. The next one, our frequency, is the number of times that one of the outcomes is observed. So if I told you here that we flipped heads 22 times, then that means if I look at the frequency of heads, that is equal to 22 because that's how many times it occurred. And then the last one, a relative frequency, is an outcome or of an outcome is the frequency of the outcome expressed as a fraction or percentage of the total number of trials. So what it means is our relative frequency is how many times our outcome occurred over the total number of trials that we have. So if we look at this problem that we did for our heads, it would be 22 over 50. And it says that you can write it as a fraction or a percentage. I'm going to most likely have you guys do it as a decimal throughout. So 22 divided by 50 will give me 0.44. If you did write it as 44%, that would be perfectly fine as well. But I'm going to want you writing it as a percentage or a decimal. All right, so those are the key terms that you need to know. The next one that we're going to do is the exact same thing as relative frequency, but it's just saying it in a different way. And then let's go through it. All right, before we do that, let's just go through another example. It says, for example, suppose a small plastic cone was tossed in the air 300 times. It fell on its side 203 times and its base 97 times. So the total number of trials that we have is 300 because that is how many times we tossed a cone. The possible outcomes are the side or the base because it could either fall on its side or it could fall on its base. It didn't say it can fall on the point or that sometimes it didn't fall on anything. It was one or the other. All right, the frequency that we have, the total number of times it fell on the side is 203, as it told us here. The total number of times it fell on the base is 97, as it told us here. So that tells us the frequency of each outcome. And then the relative frequencies, we're putting the frequency of the side over the total number of trials. So 203 over 300, which is approximately 0.677. And then the relative frequency of the base is 97 over 300, which is 0.323. All right, now the next thing that we're going to discuss is there's another word, another key term that you need to understand, and that is experimental probability. All right, it is the same as relative frequency. The only difference is we write it in a specific way. If you see here the experimental probability, it's saying P, and then we talk about whatever outcome that we want or outcome that we're discussing, and then we say what is the likelihood of it happening, so 0.677. All right, the difference is when we're writing experimental probability, we write it in this format, which the P stands for probability. We write the outcome. So if I write base, then the probability of the base happening is 0.323. All right, there's this one example that I typed up, and let's just go through and answer this real quickly, and then we'll move on to the next section B. A die is rolled 50 times. 12 times it lands on the number 4. Well, what is the number of trials? Well, that's the total number of times that we performed this experiment. So that's 50. What are the possible outcomes? Well, we're rolling a die. Well, the total possible outcomes we have on a die is we can roll a 1, we can roll a 2, a 3, a 4, a 5, or a 6. What is the frequency probability of the number 4 landing? Well, it landed 12 times for the number 4. So that means 12 over top of the total number of trials, which was 50. All right, now I will want you to express this as a fraction or a decimal. A decimal or a percentage. So this will then be 0.24 or 24%, whichever one you want to do. Your call. Make sure you're bringing your calculators into class though. All right, that is it for section A. Let's move on to section B. All right, for section B, this is going to be very quick. All it is probabilities from table data. So we only have one objective, is to use the table of data to find the probability of an event happening. So I'm going to give you all this data. You need to be able to read and interpret what that data is saying. That's the only objective for today, for this portion of the video. So this is the only question we're going to do. If I give you this table, what we would need to do, so if we're given the data in a form of a table or graph, we can use relative frequencies to estimate the probabilities of various events. All right, so for here, if I ask you to find the probability that exactly one apple, let me go through the question first. I'm trying to rush, I'm sorry. So it says, George keeps a record of the number of apples he eats each day. So here we have 0 apples. That means 10, and the frequency of it occurred was 10. That means 10 days he ate 0 apples. Here we have 1 apple. 17 was the frequency, so that means 17 days he ate 1 apple. Here we have 2 apples. The frequency occurred was 12, so 12 days he ate 2 apples. And so on. Three different days he ate 3 apples. Sorry, I had to pause the video because NG and a few other classmates want to come and bang on the door. So now the number of apples he ate 4, and the frequency occurred was 1, so that means 1 day he ate 4 apples. So what is the probability that he eats exactly 1 apple? Well, the first thing we need to know is we put the number of times that outcome happens over the total number of trials, or in this case, days that we do. So that means first we have to add up all of these frequency, because that tells us how many total days he kept track of the amount of apples that he ate. And we add this up, it gives us 43. So we know the total number of trials is 43. Well, how many days did he eat exactly 1 apple? Well, here's the 1 apple, and he ate it for 17 days. So that means we will look at 17 divided by 43. All right, so now it asks us to estimate the probability. And once we see the probability, that means that we are going to be doing an experimental probability. So that means we need to write it a specific way. So we will write P because we're talking about probability. We say what event we're talking about. So we can say 1 apple. And then we write it as a decimal. So 17 divided by 43 is 0.395. So we can then say is approximately 0.395. Or if you wanted to write it as a percentage, you can say 39.5%. If I ask you to round to the 100th, then you have to know how to round to the 100th. All right, so now for B, it is at least 3 apples. So you need to know what it means when we say at least. So does 1 get included when we say at least? No. At least means the minimum we can have is 3. So if we look at our chart, that means we're focusing on the times he ate 3 or more apples. So that means we're looking at the times when he ate 3 and 4 apples. So if we look at the outcomes that we have, we're looking at 2 cases, when he ate 3 apples and when he ate 4 apples. So how many times did he eat 3 apples? Well, 3 different days he ate 3 apples. How many times did he eat 4 apples? 1 day. So that means the total number of outcomes that we're looking at here is 4. So in our fraction, it's going to be 4 over 43 this time, because we're looking at the total number of apples that he ate when he was looking at 3 apples or 4 apples. All right, so now we will need to write this because it is going to be our experimental probability. So it's a probability of at least 3 apples. And then we write it as a decimal. So 4 divided by 43 is going to give me approximately 0.093. So that means it will be 0.093 here as well. We write it as a decimal, or if you wanted to write it as a percentage, 9.3%. Either way is acceptable. All right, now the last thing that we're going to discuss is going to be our section C, which is sample space. All right, the objective is to understand what a sample space is, and then to know how to write out a sample space using these three methods: a list, a grid, or a tree diagram. All right, once we go through all three, I really don't care how you do it on the test. Whichever one you think is the best one is the one that, or the easiest, is the one that you can use. When you go through questions on the textbook, it might say use a tree, use a grid, or use a list so you can practice. But on a test, you can use whichever one you feel comfortable with. So before we can go through listing out our sample space, we need to know what that is. And a sample space of an experiment is a set of all of its possible outcomes. So if we're just flipping a coin, our sample space is simply a heads or a tails. That's nice and easy. Well, what if we're flipping a coin and rolling a die? Well, this changes because now we can get a heads and a 1, we can get a heads or a 2, a heads and a 3, and so on, all the way up until the very end, because we have all these different possibilities. And not only can we get the heads with the 1, we can also get a tails with the 1. So we have all these different possibilities. So we need to be able to list all these out because it helps us figure out the probability of an event happening. All right, so I'm going to go through the 3 different ways that we can do this, and then there's one example that we're going to do. The first way is just a list. And really, a list only works best when you only have one event happening. So in this case, we're just spinning a spinner that has 4 different colors. There's no other event that's taking place that's different than the spinner. So in this case, we will just list it out. So we just list all the possible options. We can have purple, we can have blue, we can have red, and we can have green. Those are all the options that we can have in this spinner. All right, the next two, a grid or a tree diagram, these ones are more useful when you have 2 events that are taking place, like flipping a coin and spinning a spinner that only has ABC. All right, so we're going to look and see how can we list these out. So first, let's go through a grid. All right, well, first before this, we have a coin, and the coin we have a possible of a heads or tails. Then we can spin a spinner. So with this spinner, we have a possibility of getting an A, a B, or a C. So we have these 3 possibilities. Right? When you're listing a grid, you can essentially just create an XY axis. And it doesn't matter what you put in your X or your Y, but I'm going to put here, I will put my heads and I will put my tails. So here, I will put the option of getting an A, a B, and a C on my spinner. So I put my spinner on one side and my coin on the other. All right, now, these, if you have done anything with Punnett squares in science already, then it's the exact same thing essentially where we're looking to see where they meet. We just kind of multiply or look at them together. So here we look and see, all right, well, what happens when this heads and this A meet? That means that's a possible outcomes. We can have a heads for the coin and an A on the spinner. Here where this H or the heads and the B meets, that means we can get an H on the heads on the coin and a B for the spinner. Here where the H and the C meet, that means we can get a heads on a coin and a C on a spinner. Here where the T and A meets, same thing. We get a TA. Here we get a TB. Here we get a TC. So this tells us all of our possible outcomes. And then we can go ahead and list them. Nice and easy. Right? Before, it might have been a little bit trickier if you tried to just list these, going through these in your head instead of listing them all out using a grid. All right? So it's important that you guys can use a grid or the tree, which I'm going to show you next, because the tree is usually what I'll use. All right, so that's one way. All right, now the next way that you can do this is by listing a tree. So when you use a tree, we start with our first thing that we can have. So we flip a coin. When we flip a coin, we can have a heads or a tails. Then we look at the next event that can take place. We can spin a spinner. We can get an A, a B, or a C. Then we spin the next spinner when we get to tails. We can get an A, a B, or C. So starting from this point here, our starting point, we look and see what are all the options. Once we get to heads, we can have the HA occur. We can have the HB occur. And we can have the HC occur. Then we can look at the next route. We can go down here and flip a tails first. And we get a tails and then spin an A. So we can get the TA. We can get the tails and we can spin a B. so then we get to TB. We can get a tails, and we can spin a C, so then it gives us the TC. All right, so regardless of which method you use, the grid or the tree, we still got the exact same results. All right, that's why I don't care whichever method you use. All right, there's one example, then we're done with this video. All right, this example, it says to specifically use a tree. So illustrate, using a tree diagram, the possible outcomes when drawing 3 counters. So that means 3 different events are happening. We're doing 3 times. And the bag contains red counters or blue counters. So the first thing is we're starting here. We draw 1 counter. We can have 2 options, red or blue. All right, now regardless of what happens first, from this point, we're drawing another one, and it can be red or blue, red or blue. And then when we draw our third one, same thing. It can be 2 options, red or blue, red or blue. So every single time that you create a new event, you're looking and saying what options can take place. All right, and now from here, we're going to list out all the possible outcomes. So we went red, we can go red, red, red. So that's one of our outcomes, red, red, red. Then here, we could go red, red, and blue. So then our next one would be red, red, and blue. Here we can go red. We already finished off all these red. So red, blue, red. So red, blue, red. Then after we get that blue, we could have landed with another blue or picked another blue out. So red, blue, blue. Then if we picked blue first, we could go blue, red, red. Then the next one, we could have went blue, red, blue. The next one, we could have started with the next one would have been blue. So blue, red, blue, or I'm sorry, blue, blue, red. And then the last one, we could have did blue, blue, blue. So I like the tree because I think it's easy for you to follow along. But if you think the grid is better or easier, then by all means use that. But here we can list out every single possibility that's happening by just following our paths that we can take along this tree. All right, that is it for this video.